Hey guys, today I'm going to be talking to you about the methodology and evaluation metrics that we've used for our project, that is melanoma detection. So this is what we're going to be talking about today, the methodology and the evaluation metrics. So the three main methods that we've used is first pre-processing and balancing the data, converting the data into a NumPy array, and then designing the custom ensemble machine learning model itself. So coming to data pre-processing, we did some minimal processing where we filled in the gaps and the missing values. Otherwise, the data was pretty accurate because it's already been vetted by subject matter experts. We performed some compression to the images, so we converted them to a 128 by 128 image dimension because otherwise the images were too large for our processing. Then augmentation and balancing. So initially we had only 1,000, approximately 1,000 data points for melanoma. So we've used a generative adversarial network, or a GAN, to create additional data points based on the original data points. So it was a conditional GAN. And then we have combined the data from vascular lesions and dermatofibrosis into our melanoma data set. So totally we are using 4,000 data points, and then we're going to split this into 60, 20, and 20. Yeah, and then the coming to the model design. So our model is a unit which is connected to a flattening layer, which are then connected to two further fully connected layers. So there are two nodes in the final layer, which will determine whether the provided input image has melanoma or not. So if we look at the design here that we are implementing, so the image starts at 128 by 128, then max pools so by 2 by 2, and then up convolutes, and then it goes to the flattening layer where we flatten the segmented output and then pass it to the fully connected layers here. And we have two output nodes which indicate whether melanoma is present or not. Moving on to the evaluation metrics, we are mainly using a confusion matrix. And based on this confusion matrix, we are planning to perform some, demonstrate some, measures. So confusion matrix indicates four types of errors: so true positive, true negative, false positive, false negative. Then from this, we are going to be measuring the accuracy. So if we go to the next slide, we can see accuracy is, we are going to be doing A plus T divided by A, B, C, D. So basically, the ratio of correct predictions to total number of predictions. Similarly, we will also be calculating precision, recall, and F1 score. So precision is a proportion of true positive versus total positive predictions. Yeah, and then F1 score is the harmonic mean of precision and recall. Finally, we would also be doing an AUC ROC curve analysis. So basically, we are going to be plotting the recall versus the false positive rate at various thresholds. So this will indicate how the model is able to, differentiate between non-melanoma and melanoma cases. Yeah, this is an example of a confusion matrix. Thank you for listening. Have a good day.